Hey y'all, so in this video, again, this is going to be an optional video. I'm going to be going over the Unit 2.5, Lesson 1.2, aka the async lesson that we had last Friday. So if you feel comfortable with the material that was covered then, go ahead and skip forward. If not, stick around. I'm going to be going through this lesson in quick step-by-step detail. Again, this was your agenda. We're still working with these same objectives that we were before we had our two async lessons. Being able to prove that the slope between any 2 points on a line is the same by writing a justification that the rate of change is the same between any 2 points. So for today's exit ticket, this day's exit ticket, that was the task that y'all were asked to do. And it started all here with this poll. So this poll asked you to figure out which of the following is not a criteria for similar triangles. Also asks you to do now. Remember, my criteria for similar triangles is that they are congruent with their angles / have a similar shape, proportional corresponding sides have to be facing the same way, and delta y over delta x is the same for all triangles. So in this case, A, B, and D are all three of my criterias. This is the only one that isn't exactly true and doesn't have to be true every single time. Then they don't always have to face the same way. There are chances where we can have congruent triangles where one, whoops, get the pen, where one can look like this, and the other one might look like this. Even if they are not facing the same way, they have the same interior angles, same shape, and if we just flip it around, they will be congruent. So this is what we mean when we say have to be facing the same way as not one of our options. So go ahead, erase this up. Make sure that you hit submit, and we'll go on. Again, make sure that as you go through these async lessons, you're also taking notes. I know it can be a little bit difficult, especially if you don't have me or Miss Rocky to kind of let you know where to stop and take notes at. But my best rule of thumb is anything that looks like a new vocab word, definitely make sure that you stop, take notes about. Anything that is confusing to you that you might have questions about when we come back in person, also make sure that you are taking notes about. Otherwise, let's go ahead and go back into our previous lesson / key points in vocab. Again, you should have all 5 of these vocab words in your notebook already. If you do not, definitely take the time, go back, write them down again. But the one that we are working on today, again, is similar triangles. They have corresponding angles, congruent, the corresponding sides are in proportion. And their change in x, or change in y over their change in x should be the same if they are similar. Again, this is the criteria for similar triangles. This will be coming up in your exit ticket for today, so make sure that you have these written down. Same shape, but not necessarily the same size. Corresponding angles are equal, and corresponding sides are in the same ratio. So this is pretty much our dy dx, or delta y delta x, just worded a little bit different, but also you get a good visual representation. The new key point for today, and where we're going in the Unit 2.5 lesson number 2 on Wednesday, is the ratio of x and y, where when x increases, y increases, and when x decreases, y decreases. This is the definition for proportional relationships. We're going to be using this definition throughout the next few lessons coming up here Tuesday and Wednesday to help further define what we mean when we say similar triangles. So again, this is something that for sure you want to write down as new vocab, as a key point for today. So if you didn't write that down last time, pause the video, take a second, and write that down. Oops, don't want to do that. And then again, over here is another visual representation that you can use. A couple of examples of proportional relationships and some non-examples. Again, if you feel like those are going to be helpful for you, make sure that you bring them along, keep them moving. Let's go ahead and continue on. So this is something new. Again, something that you also may want to write down, because if you are confused on how to solve certain problems, use this information to help find the right next steps. So it might be a little bit hard to see, but when you look close on it, it says, how do I find slope? And it tells you what to start with. So we start with the information that we have, information that we are given in the problem. Usually that's either going to be given coordinate points and coordinate pairs, so those x and y pairs inside of our parentheses, or it's going to be a line on a graph. I remember last class, a couple of us had questions on when to use the y2 minus y1 over x2 minus x1, and when to use delta y and delta x. So this is kind of a good way to let you know which formula that you should be using. If you are given a couple of pairs of points and that is the only information that you have, you're going to be using the y2 minus y1 over x2 minus x1 slope formula. If you are given just a line on a graph and no other information aside from that, you're going to choose at least two different points that are on your line to find slope. Again, as long as they are on your line, you can clearly tell which numbers they are. So as you count over, it makes it a little bit easier. You need to find at least two. So again, this is just a good step-by-step instruction ladder showing you how to get to your solutions. If you use the line on a graph and you prefer the equation, you can always just find the pair of points and then plug those points into your equation. If you feel like it's easier just to count the spaces, absolutely go through and continue on with this red path. Again, this is just another way to help you get through some problems just like our practice one for today. So again, another video just kind of showing you a couple more different examples for how to find slope using those similar triangles. So in this problem, using the graph below to answer the following questions, you may label the smaller triangle, the angles A, B, C, and the larger triangles with D, E, F. Now, I haven't shown you explicitly exactly what this second part means, but this first part, question number A, is what I want y'all to be able to do with these lessons. So finding the slope of the line and showing your work. So going through and looking over these, looks like most people were able to pretty well draw these out. So this, for example, this is a 3, goes up 2 spaces. So I saw most people got this part. Oops, not my straightest line. And this part, so that was, I believe, 9. This one is 6. But where I'm seeing some confusion is students will set up these two triangles, again, 3 and 2, 9 and 6, and then don't know where to go next with it. So remember, these 3 and 9, these are my delta x's. Get a separate color. So this 3 and this 9, those are what we call delta x. And so that means my 6 and my 2 are my delta y's. And so I saw a couple people kind of flip these around, not exactly do what we should have been doing. But remember, delta y goes over delta x, 2 goes over 3. So my first fraction pair is going to be 2/3. And I'm trying to figure out, is this equivalent to 6/9? So again, right now, finding the slope of this line, I'm counting out. And now I'm going to start answering the second question, determine if the triangles formed along the line are similar, using any method and the criteria for similar triangles. And again, you're asked to explain that. So, the criteria of similar triangles, remember, congruent sides, proportional sides, and congruent angles. We haven't really tested out how you can find congruent angles, but for congruent sides, the best trick that you can have is think about what times 3 is going to get you 9. I'm going to change my color really quick. So in this case, that's going to be 3 times 3 is going to get me 9. In order for this to be a proportional triangle, both numbers need to be multiplied by the exact same constant, in this case 3. And if they both give you the correct solution, it is a proportional relationship. So you can do the same thing with your fractions, multiplying both the top and the bottom by the same number. In this case, I'm multiplying top and bottom by 3. And in each case, I get the correct solution, 6 and 9. So this tells me that both of these are proportional. So I can either use delta y over delta x as my justification because they are all consistent. If you plug it into a calculator, you're going to get 0.66 repeating for both of these fractions. Again, this little bar on top just means repeating in case you haven't seen that in your decimals. If you want to write 0.67 because you rounded, that's also fine. But again, it just pretty much just means that your slope for both is the same when you plug it into a calculator and simplify. And when you multiply them out, they are also going to be the same. So I'm going to go ahead and stop this video here. Again, if you have questions, I'm going to be posting on Google Classroom for our next lunch help session. Keep an eye out for that. Otherwise, continue on with the rest of today's lesson, and I will see y'all later.